Well, hello everyone. Lovely to be here. It's my first in-person Ruby conference since, the before times. So yeah, it's great to see so many people. And yeah, excited to be here, even though I had to leave my kitten at home. This is Elrond. Got him on Tuesday. Anyway, onwards from cats. And I wanted to start with an unfair question, which is, what's wrong with this code? Some JavaScript. There's this sort users function. And I do it by comparing the last name of the users. So I wondered if anyone had a guess at what's wrong with it. Yeah, pretty close. So actually, in this application, last name is nullable because in this application, one way users get created is you can invite a user. So there's a form, you put in an email address, they get an email, they click on the link, and then there's some details. Until they've done that last step, users don't have a name or anything other than the email. And it's unfair because, well, how are you supposed to know that this flow exists? In fact, looking at this code, you don't even know where users has come from. Has it come from an API? Is it just some static data in the front-end code? And I say it's unfair. I also think it's representative. It's not easy to understand how back-end concepts materialize in the front end. It's very easy to make mistakes. Like I have this blind spot in our code base. Is it last name or is it surname? And I type the wrong one. I should get the wrong one no worse than 50% of the time. It's more like 75%. Anyway, so today we're going to talk about how we might try and fix this. So I am a long-term Rails developer. So I remember Rails 1.0, simpler times. I'm the lead engineer at Skiller Whale. What we do is live team coaching for tech teams. So helping engineers be better engineers and more productive as a team. The main relevance of that to this talk is that since joining Skiller Whale, since it's quite a small team, I'm doing a lot more front-end development. So these problems are becoming my problems. So now I want to fix them. So how do we solve this? You might think, well, we can add more front-end tests, and by more I mean some. But I want something a bit more systematic that doesn't rely on me remembering to add tests and tests to cover all the cases. I think if you were to ask a front-end person, they'd say, hey, well, you should be using TypeScript. That's great. So what is TypeScript? I mean, other than an open source project out of Microsoft. The Wikipedia page, paraphrasing, says TypeScript adds static typing with optional type annotations to JavaScript. So a bit of a mouthful. And also worthy of note is that unlike kind of sorbet and RBS and so on in the Ruby world, TypeScript is something that has been very widely embraced in the JavaScript world. So start actually going in the opposite order of the sentence. So superset of JavaScript. What that really means is that any valid JavaScript is also syntactically correct TypeScript. There might be type errors, but the syntax is still good. And that means also that it interoperates with JavaScript. So if you have an existing code base, you can convert it to TypeScript one file at a time. It's not like, oh, I need to do a complete rewrite. Type annotations, these are things you add to variables, functions, classes. And what will start happening when you add them is you'll say, hey, you said this thing needs an array of numbers, and you've given it an array of strings instead. And these are optional. You can add them gradually. You can have a TypeScript file with absolutely zero type annotations in it. It might not do a lot, although it will still do something because it already has type annotations for all of the JavaScript standard library and the DOM interface and so on. But you don't have to add them until you need them. And it's quite good at inferring them. So you don't need to add many type annotations for it to start being useful. Then lastly, static. I mean, this means that it checks the code, but it's not running the code. So there's no runtime checks. There's no is this object or whatever. The TypeScript you write gets checked and then converted to JavaScript, and that JavaScript has no trace of the TypeScript left inside it. But it does kind of understand statically what those runtime checks would do, and we'll talk about that more later. And then kind of lastly onto what is TypeScript. There are kind of two categories of type systems, nominal and structural. So nominal, if you use sorbet, you're using a nominal type system. Although these two classes kind of look and quack the same, as we say, from the previous sorbet, they're two different classes. You can't take a user and pass it to a function that expects a company. Structural typing is a bit different. So these two TypeScript types, they've got an ID property that's a number, a name property that's a string, so they're interchangeable. This is perfectly valid TypeScript. I create a user, I assign this object to it, that's okay because it has an ID and a name, and then I assign the user to a company, which kind of doesn't make sense when you say it out loud, but TypeScript doesn't care about the names of the types, it only cares about the structures. So, structural typing. So, what do types look like? These are kind of your building blocks. So you've got primitive types, so numbers, strings, booleans, that sort of thing. You've got literals. So this might seem a little bit pointless, but it will become useful in a few slides' time. So this string Fred is a type, and the only member of that type is the string Fred. False is a type, and the only thing of that type is the value false. You've got your objects, so standard JavaScript key-value pairs. Function, so here's a function that takes a user and returns a string. You can do arrays of things, and then we have some special types that are kind of escape hatches for working with untyped code. So these are kind of the building blocks. Everything uses these things, and then you can combine them in interesting ways. So you can have unions, so this thing is a number or a string. You can have intersection, so this object has to have all the properties a user has and all the properties that user details have. You can index into types, so if user is a type, then user square brackets name is the type of the name property. You can have generics. So if I could have an HTTP response type which has a status code and headers, and then a data field, and the type of the data field is given by this type parameter. And there's lots of complicated things you can do with generics and conditional generics and so on. Then you have utility types, and these are things like give me the type of the return value of this function, or give me the type of the arguments of this function. So can write all these types in these fun ways. What's TypeScript going to do with this? And this is a very quick overview. There are lots of other sort of workflow things that TypeScript does. I mean, really, what you're trying to work out is what things are. You've got something in your editor, what is it? And I worked in plenty of front-end code bases where this was not at all obvious. Like, here's this thing, it comes from this thing, it comes from this thing, it's a prop from this thing, and that's coming from that API call, and you've got to go through like 4 layers of indirection before you work out what it is. And then once you know what things are you using them right? Can I do this operation on this type? And you can get this feedback on the command line. You can run the TypeScript compiler, and it will say, hey, you're trying to call this function, but this function might be undefined. Or you can get in-editor help. So this is exactly the same bit of code that is checked for me there. I got a parameter on delete. It's a line item action or undefined. If it was a line item action, that's okay. But if it's undefined, then trying to use it as a function doesn't work. And TypeScript is a language server, so any editor which supports the language server protocol will display this stuff. So that's VS Code, Sublime, Emacs, and basically any mainstream code editor at this point. And the live feedback is really good, especially things like typoing property names. You get told that you misspelt it kind of before you finish typing it, really. So what does that look like in practice? So you could have a React component. I can say the type that it expects as arguments. So I expect a user here. If I pass something that's not a user, or I forget to pass a user, or I pass something that I've called user but doesn't have the right properties, those are all errors. If user didn't have a name, this would be an error. As I'm typing user dot, it will suggest things that properties that it knows exists. If we come back to the code I started with at the beginning of the session, I mean, here TypeScript is happy because you said last name is a string and I'm comparing 2 strings. But if you say that last name is string or null, then it's like, hey, wait a minute, this thing is possibly null. And it would also show up, obviously, if you ran TSC to run the compiler. And I've got one last TypeScript concept for you, which is narrowing. And that's when TypeScript can work out that your data has a more specific type than what you told it. So this is all about what you can infer statically. So if I've got this code here, this function that takes a number or a string, then inside this if thing, it knows that the value is a number. It's not actually evaluating type of value, but it understands the JavaScript syntax, it knows what the type operator does. It knows what the comparison would do. So like, hey, I know the value is a number here. You might think this is pretty trivial. Maybe slightly less trivial is that it understands that in the else branch is a string, because it knows it started with something with a number or a string. If in one branch it's a number, then in the other branch it must be a string. Let's have a look at something a bit less trivial. This is kind of like an invoice page. So you get all these line items compared to either money that's been given to us or services that we provided. Maybe the most important object here are payments. We like to get paid. There's a type field. So this is a type field which has the literal type payment. It has to have this string. So like single table inheritance or delegated types in Rails. Then it has some properties about the payment. So an ID, an amount, and a date. Another important object in our invoices are the coaching sessions. So this is the service that we provide. And here type has to be the string session. You get some properties that are the same as payment. In fact, they're in common to all line items. And some other ones that are session specific. And then I can say that a line item is a payment or a coaching session or a refund or whatever other properties I have. So anything that's displayed by the invoice is a line item data. The fancy word for this is a discriminated union, because it's a union of things, but there is a property of each thing in the union that tells you what it is. By convention, this is normally type, but it can be any property you want. TypeScript doesn't actually care. So this code, which operates on a line item, we don't know what kind of line item it is, but it doesn't matter because everything has an amount. So I can print out the amount just fine. This code, however, is incorrect because line item could be a coaching session, in which case logging the session ID is fine. But if it was a payment or a refund, this doesn't make sense. And TypeScript can say, hey, wait a minute, it doesn't exist on this type because it doesn't exist on this branch of the type. But if I check first, is the item type a session, then within this branch, line item, or the item has been narrowed to type coaching session. So it knows it's OK to access this property. So you can see that even though it's only doing static things, it understands enough about the language, enough about what would happen, that it can tell you quite a lot of things. And we use discriminating unions pop up all over the place. So they're good for if you do have single table inheritance or delegated types, but also anytime you have similar objects is also very good. So we often use it for when a form can have either a saved object or an unsaved object. They're mostly the same, but the saved object has an ID and a created at, some extra metadata that the unsaved object doesn't have. But I still want to use the same form, but not have it blow up or accidentally use properties that don't exist in one case. Yeah, this is when you try and play with your cat toy, but actually it's a bit scary and it might attack you back. So I just said that you can do a lot of compile time, but I said there's a bit of an elephant in the room, which is there is obviously going to be data which is completely unknowable at compile time. If you have a web application that never talks to an API, never talks to a backend of any sort, that's pretty limited, right? At some point, you get data from the outside world. You might have some code like this in your application where you make a fetch call to get some data. So backticks are how you do string interpolation. In JavaScript and TypeScript, you check whether it's exceeded because you're a conscientious developer. You pass the JSON, and this is the problematic line. This isn't like a cast, this is an assertion. This is you are telling TypeScript, trust me, data.user exists and it conforms to this type. It may or may not, TypeScript doesn't know, it's giving you a free pass on it. There are runtime schema libraries like Zod or Typebox and so on that will do runtime checks. But part of what I was trying to do is I want those static checks. I want to find mistakes without having to write lots of tests that exercise all the code paths. So really, the question is, how do I know that my types are correct? If I think that user always has a name, why on earth would I write this type? If I haven't realized that name can be null, I'm just going to write this type, in which case I won't get that error flagged to me. So yeah, everything kind of depends on the least glamorous bit of the project. So, have we made any progress? I think so. I mean, we've added quite a lot of safety. We've got this sort of consistency within the front-end world. We've probably got a very small number of places where we're writing down what those assumptions are. there's probably not that many places where you're fetching data from remote sources and they're easy to identify. But can we do more? I mean, this is one of those rhetorical questions where if I said no, I'd be severely under time. So I want to talk about JSON schema next. So a JSON schema is a JSON document that describes the expected structure of a JSON document, which sounds a bit circular. And then, of course, there are meta schemas, which are JSON schemas that describe the structure of JSON schemas. Turtles all the way down. If you've ever used OpenAPI or Swagger, that's kind of a dialect of JSON schema. So this is a very simple schema. It's an object, so as opposed to a string or an array or something like that. It's got some properties, and I'm saying these properties are mandatory properties because they default to optional in JSON schema. This is another schema. This one, titles only ever kind of human-facing things. It's still an object. This one has a user's property type array, and the type of things in the array are given by whatever's in this other file. So you can compose schemas from other schemas. In Ruby, there are at least 2 gems that you can use. I've used both of these, JSON schema and JSON schema. I write all my schemas as plain files on disk. Actually, I write them in YAML because it's a bit easier to read than JSON. There are plenty of tools that will generate things for you. So Grape API Py will generate Swagger files for you, but you don't need to. And part of what I wanted to do is I wanted to try this, and I didn't want step 1 to be rewrite your API in with this tool and then see if it's useful. So I've stuck with the plain files. So what do we do with them? The first thing we do a lot is check using specs. So fetch some data, expect it to conform to a schema. We do runtime assertions. I mean, probably only in development, but it's good for when you haven't written those specs yet, and you're obviously definitely going to write them at some point, but maybe later. Or if you encounter corner cases in development that you didn't think could exist. You might be thinking that these 2 things, they're kind of quite similar in what they're doing. And while JSON schema might be useful, if I have this Ruby world which is checked with schema files and this TypeScript world which is checked with types, then I still have this problem of making sure that they're the same. Can I write this only once? And again, if the answer was no, this would be a very short talk. So the answer is yes. There are several tools that can do this. I've been using one called JSON schema to TypeScript, which seems to work very well. There are things that work in both directions. I much prefer schema to TypeScript because JSON schema has much richer types. So to pick a trivial example, in TypeScript, you have the type number. Whereas in JSON schema, you can say number, but you can also say integer, or you can say float, or you can say integer with a minimum and a maximum value. Strings and TypeScript are just strings, whereas strings in JSON schema, you can have patterns, you can have regular expressions, you can say it must be an ISO 8601 formatted date. That extra information won't make it into the TypeScript type, but it will make your Ruby specs that much more precise. So it kind of does all the things you'd expect it to do. I'm often quite wary of tools that generate code for me. I used to write a lot of Swagger definitions via Grape and Grape Swagger. And sometimes I'd spend an hour, like I knew the Swagger I wanted to write, but convincing Grape Swagger to generate the correct Swagger was like, this is more trouble than it's worth. I really haven't had that problem with this library. It nearly always does what I want it to do, and if it doesn't, it's got a good, easy-to-use escape hatch for saying, just use this type. So if I start with this schema, which I've written in YAML to make things different, it's for a snooze object. I've written a nice description of what it is. I said it's a string or a null, and I'm saying that it needs to be an ISO 8601 date. Actually, and in with the JSON schema gem with an A, you can register your own formats as well, so you have application-specific things. I run this through the converter thing, and I get this generated type. So we haven't got the format anymore, but we've got the comment with the description. We've got the property itself, which is string or null. So yeah, this is what I was hoping would happen. Now, when you have a comment formatted like this with the 2 stars at the beginning, when you hover over it in your editor, then that comment comes back up. which my front-end colleagues have found quite helpful for understanding what's going on. So where do we use this? I mean, the short answer is wherever we can. The longer answer, so we have a lot of pages where the page is an HTML page or a regular HAML template, but we have elements on the page that get replaced at runtime with React components. And those React components, their initial props come from data attributes on those. So, and we check those data attributes. API responses is kind of an obvious, the most obvious use case, and we do that a lot. And also action cable events, because we use quite a lot of action cable. So talk a bit about action cable. So we have a Rails app that we use to deliver the actual coaching sessions. And that is mostly run through action cable. So when the coach wants to go to the next slide, that sends a message down the channel to everyone in the session telling their browser to display this new bit of content. So this is the schema file for the channel. This is a JSON schema construct which says that whatever it is, it needs to match one of these things. These are actually references to things that are later on in the file. We run this through JSON schema with TypeScript. We get these generated types. So on the slide event, there's a type field and then some data about the next slide. If it's a user join event, then again, a type field and then some data about that. And this is another discriminated union. They do come up all over the place. And then we have some code that actually processes the event, so the action cable subscriber code. So this does a switch statement on the type field. So here we get more narrowing. So within this case statement, the type of event has been narrowed to the update slide event. So it knows that slide exists and it knows what properties it has. User join, same thing. This one is the interesting one here. If I haven't forgotten any events, this shouldn't be possible. If there are two events, I've handled both of them. If that were to change, though, I would quite like to know about it. If someone's gone and added a new event, then I need to add some code here for this function to be valid. So this assert never function looks like this. So it's saying it expects a parameter of type never. And never is this special type in TypeScript for things that shouldn't happen. So if we come back here, in the default case, event has been narrowed to the type never. Because it shouldn't be possible for it to happen, the type that it narrows to is never. But if I were to add a new event, then instead of narrowing to never, it would narrow to the union of the types that I've forgotten. And you can't assign that to never. So here we'll say, hey, I expect never, but you gave me, I don't know, user left event. So I think I quite like this, this flow. You know, if I need to add a new event, I have to add it to the schema file, or my Ruby specs will say, hey, you produced data that doesn't exist. Once I've added it to the schema file, my type and run the type generation, then TypeScript will start complaining, hey, you're not handling this new event. So you kind of get this sort of easier to not forget things. I started off with all my types in one file. I think you can imagine that got quite out of hand quite quickly. The way you organize it now is have this what I call sort of the type root files. So these have, for reasons, have to be JSON files. They tend to be, you know, a group of functionality. And each one of these gets turned into one TypeScript file, which also means you can import one without importing the other, and you don't have to have unique names across all of them. And I store them in a generated folder just to make it even clearer that, you know, don't edit these by hand. There's a banner at the top, but you don't often get, if you're looking at a GitHub diff, you don't see the banner at the top because it hasn't changed. These sort of root files, they reference files that correspond to like properties in an individual page or responses for APIs. And then those tend to reference the raw type. So the user type obviously turns up in loads of payloads everywhere. The invoice type probably turns up in both the get invoices response and the get singular invoice, and maybe as a return value from update invoice. So these can all refer to each other, and you don't have to repeat them too much. And yeah, you get kind of this kind of directory hierarchy. So where have we got to? So we've got Ruby code that generates data. We've got schema files that describe the shape of that data with specs that enforce that everything matches these shapes. We've got TypeScript types from that same schema, and then TypeScript that's enforcing safety in the front-end code. So this is kind of pretty close to this end-to-end type safety thing. And say it's been a big help to us. It's enabled us to do quite aggressive refactors without worrying about have we forgotten one place where we use this thing. There is one more thing that I wanted to talk about, which is I've still got this typecast, well not cast, this type assertion, which still feels like an accident waiting to happen. So is there anything we can do? I've got several colleagues at Skidder Whale, and they write the material for the coaching sessions we do on TypeScript. So they show me this trick. So we've already got generated types for all this. So we've got a user, this is the individual user. We've got the type when you fetch one user out of the API, a type for the sort of the collection endpoint. So far this is fairly basic stuff. This is a bit more interesting. So we've got a path where for the collection endpoint. We've got this as a template literal type. It's sort of like a type, but it's sort of like a pattern. So it will match anything that is created at runtime with interpolation, where the interpolated value is a number, and with this user's prefix. And then we've got this API type, which is a bit of a funny thing because there are no objects in our code base ever that actually conform to this type. The only thing this thing is doing is creating a mapping. It's creating a mapping between basically /users and the response type for that endpoint, and from the users/number pattern and the singular response type. The production version of this is more complicated because you want to have multiple response types per path because you've got different HTTP methods, and you also want to show what is the type of the payload that you send as well as the payload that you receive and so on, but it's the same principle. And then this is a bit intimidating, but we can step through it. This creates a new type, which is the union of all the keys in the API. So this is just either the show path or the index path. So one of these two strings or patterns. This is a generic function, get API. It has one value that you pass to it, which is a path. And path is anything which extends the API path's type. So in practice, that means it has to be either /users or /user/number. We fetch the data as before. We pass the JSON, and then we've made the type assertion rather different. So API here is the mapping. Path here is this value that is one of those mappings. So this, when TypeScript does a type check, it evaluates to the correct response. And this is all happening at compile time. So what that means is if I write this code, TypeScript knows there is an index response. And the data.users is this array of users. I don't have to actually write it I only have it in the API definition file. Same thing here, I've got this method for loading one user from the database. And it knows this is a user. If I typo it, so I put /user rather than /users, then it will say, hey, basically, this isn't an entry in the mapping. So we found this very useful. There is one limitation in that you have to call it like this. So get API, open backticks, and then a string. You can't get that string from anywhere else. So if you say JSON API and you get a links attribute that says this is the URL for the next page, it's not going to know about that. So you do have to, as it were, bring some of your routing or knowledge of what the routes are into your TypeScript code base. But we still find it very useful. And we're kind of left with just this one file that defines all of our API mappings. The paths we generate from the routing helpers, so we know that they're valid. And so it's really just the mapping bit at the bottom that we need to maintain by hand. And even that, I think we could, with some sort of small annotations in the controllers, generate this automatically, but just haven't had time to do that yet. So kind of summing up, if you write schema files, generate types, and then you'll kind of get this happiness, really. Then the last slide is the most important thing, which is you can do this gradually. This isn't like, oh, next time I'm starting from scratch and a greenfield project, i.e. never. or when I have time for a rewrite. You don't need to switch to a specific API library to do this. It's always a very agnostic of which technology you use. At Skillaware, we spent best part of 6 months doing this, and we didn't like sit down and say, now we're doing this rewrite. It's just whenever I was working on something, I would convert it to TypeScript first. If I was adding a new endpoint, I would make sure I wrote schemas. If I was changing an endpoint, I would add schemas if they didn't already exist. And kind of, over time, we incrementally got to, I think at the moment, 95% of the front-end code is in TypeScript. And you get benefits way before that. Especially if you add TypeScript before you start a refactor, then you can do that refactor with much greater confidence and fewer accidental, whoops, I forgot this rename it somewhere else. So yeah, that's kind of all I had today. That URL at the top is like a Rails app, like a working Rails app, which demonstrates this if you actually want to see what all the code actually looks like. That is my cat looking curious about outside. So I'm hoping you're as interested in venturing into this as my cat is at going outside, which he's not allowed to for another 4 weeks, but you can do this today. And yeah, that's the feedback link. Yeah.
Adorable cat. Thank you for sharing her and your talk with us. Questions? There's one over here. Here.
Hi, thanks first of all. I have a question. So did you make any experiences or like maybe some experiments with using sorbet or sorbet conversion or with Ruby signature? So that is a little more integrated into the, let's say, Ruby coding flow.
Yes, actually, we use sorbet for the back end of one of our applications. I think there's a couple of things about sorbet. I mean, one, the community support isn't there. Like, if you pull a random package of npm, it's got types defined for it most of the time. If you pull a random package of sorbet of Ruby gems, it doesn't have types. The second thing is that I quite like the fact that the bit that sits in the middle, as it were, the contract between the two sides, is technology agnostic. If we end up replacing some Ruby backend bit with something else, we can keep those schema files for that refactor. If the front end, I don't know, if we start rewriting everything in ruby.wasm or something, then we still got that same layer. Another thing is that we saw schemas and TypeScript types, they're very similar because they're both structural things, whereas sorbet kind of is slightly different. And if you were doing sorbet to schema, again, you wouldn't be able to express that information. There's nothing in sorbet, for example, for saying a hash that has to have these keys. But yeah, up until the point where you're generating the response, we do use sorbet, and we find it reasonably helpful. It's not the same immediate. I haven't found it as joyful as TypeScript. TypeScript I enjoy writing, and sorbet I kind of grudgingly accept. So yeah, I think sorbet is interesting in its own right. I didn't find that it contributed hugely to this bit. I mean, it makes sure that at the point where I pass something to a presenter object that's generating JSON, that it's the right object and it behaves the right way. But in terms of actually validating what the response is, it doesn't help you too much with that, at least not in my experience.
Thanks. Any more? Yeah.
Hi. So do you have also experience with OpenAPI, which does something similar, like generating the schemes?
Yes. So yeah, the Open API specifications, they are JSON schema documents with it's kind of a dialect of it, specialized for APIs. So in a past job, we used Open API quite a lot, and we used our API with Grape, and then there's a extension called Grape Swagger, which allows you to generate Swagger files from from the Grape API definitions. We weren't using that at Skillaware, and I didn't want step one of this project to be rewrite the APIs to use Grape and Grape Swagger. especially with my experiences where I had to work quite hard to make Grape Swagger generate the correct Swagger. But I feel like you could do that. So I'm saying I used to use Grape and Grape Swagger to generate OP and API files, but at that point, someone else was consuming the front end, so I didn't care what the next step was. But if you've already got that in place, then you're already one step ahead.
Thank you for your talk, first of all, and just one detail. So when you change your Ruby code, you validate the types using your schema.
Yeah.
At what point do you actually make sure that the TypeScript types are regenerated? Do you do it on your CI, like?
There's a CI
time?
step that basically reruns the generation process and says, is the generated copy, the freshly generated copy, the same as what's checked in? So yeah, that's a CI step, and another CI step is running the TypeScript compiler to say, are there any errors? Because even if there are type errors, it will still we generate our assets with ES-build, and that ignores all the TypeScript and just generates it. So even if there are errors, you still have a website that maybe works. So you do need to run the TypeScript compiler as a separate CI step to enforce that.
And another small question is, do you automatically generate also the API types?
No, so the API, we are writing those schema files by hand to say, yeah, this is the return value of a user. I mean, yeah, maybe in future we could say maybe do it a little bit from Sorbet or kind of sync it up with Sorbet. If you're using something like Grape, then you've already got an in-code documentation of what the return type is. But again, that's not something we had in place before we started working on this, and we didn't want to have to go through a detour of adding that before we did this. But yeah, if you've already got that, then you can skip a few steps, and it is something we'll be interested in doing in the future.
Thank you.
There's one more question over there.
Thank you for your talk. As a company, have you ever considered not using REST and using like GraphQL, which is basically another type of API who takes care of all the synchronization of the types?
Not really. I mean, GraphQL is something I know at the level of I've been to conference talks about it. It's not something we've looked at seriously. We had this, and again, we had this app that worked, and we didn't have time for let's rewrite it in this other technology and see if it makes it better. We're quite a small team, and we couldn't expend that effort speculatively.
Anyone else? Okay. Thank you, Frederick.